This is a digital twin running in Unity, a real machine cell fully simulated. Let me show you how to get from an empty project to this and what's actually inside. One thing really matters here, use Unity 6.3 LTS, shown as 6003 in Unity Hub. Real Virtual 6.3 needs exactly this version, so don't grab an older one. Go to the Unity Asset Store, assetstore.unity.com, and type in your real virtual. There are multiple packages listed, but you should choose Starter 6.3, Real Virtual Digital Twin Starter 6.3. Click on it and add it to My Assets. Package Manager, Window, Package Management, Package Manager. And you should see here Real Virtual Digital Twin Starter 6.3, which we downloaded for free from Unity Asset Store, and we download. After downloading, press here Import. There's a window coming up, Import Unity Package, and we just import here. This might have taken some time, but after some time, this message will come up and we will apply the settings to the project. Now a hello window will open. We can just close this, and close this. And we'll have the demo scene here and the game window. And for starting it, we just press here on play. Here we select free aspect. If not selected, we press play on top of here and we see in the digital twin running. Everything here you see runs on three things: drives, behavior models, and signals, which are coming from interfaces. But first, let's go to the scene window for explaining you more about that. What you could do is to turn the gizmos off, or maybe I turn them on. I just deselect the 3D icons, and here I can explain you more about it. As I explained, everything here you see runs on three things: drives, behaviors, and signals. A drive turns static geometry into motion. For example, here we are having the drive running the conveyor. Or selecting the door, we are having the drive running the door. A drive doesn't need to be an electrical drive. It's just something moving something. So it could be a pneumatic or even a hydraulic. On this drive here, we have one additional thing, what we call behavior model. Here, this drive cylinder that defines that this drive is behaving like a cylinder with one bit. And we have here the signal open door. And you can see over here, the signal is connected to the behavior model. And the signal usually is coming from an interface, in this case, the TCP/IP interface connecting to a Siemens S7. In here, in this demonstration model, it's turned off because we would like to deliver a running model. So the signals are forced and controlled by a logic inside of the demo model. You can see it here, simulated PLC. And going back to this door, we can even force signals. For example, we can force this door for opening and closing, or we can unforce it. And by forcing, we can change their value by clicking on it, or we can unforce it. Now the controller is giving back the control to the PLC or to the integrated virtual PLC code. You turn an interface on, for example, here by setting it to always. And you can connect now the S7 TCP/IP, so an S7 from Siemens. In our professional version, we are having additional interfaces to Beckhoff, Keba, NCW, to robot controllers, much more than 20 interfaces. So you can also check this out. Geometry plus drives, behavior, and signals. That's a twin. And this whole demo is free in the starter. On the next video, we build one digital twin from scratch. So please subscribe to our YouTube channel. Thanks.